Solving polynomial inequalities. In the first video, I talked about what is a nonlinear inequality, and in general, at least for our purposes, we're splitting nonlinear inequalities into two distinct groups. There's polynomial inequalities and there's rational inequalities. Those are going to be fractions. They're mostly the same, but since there are some differences, I'm separating the ideas. Let's start with polynomial inequalities because polynomials tend to be nicer. Some step-by-step steps. Let's look at an example. We have the function x minus 5 times x plus 2 quantity squared less than 0. We want to solve this inequality. If it confuses you what this means, what this could possibly be talking about, maybe you didn't watch the first video, please go back and watch it. Made it for a reason, please. All right. The steps in solving a polynomial inequality, you really want one side to be 0. As I talked about in my previous video, it's easier to think about these as being above or below the x-axis. So we need one side to be 0. In this case, one side is 0 already. We don't need to move anything. This is already done. It's also factored, so that's done. One side is 0, the other side is factored. The next step is setting each factor equal to 0 and finding our VIPs. And our VIPs are our very important points. These are going to be the possible places where the function could dip below the x-axis. In this original video up here, notice that the zeros of the function are the only places where a function could change from being negative to being positive. Only at the zeros of the function can it change. There's no other place because that's where it hits the x-axis. So we need to find these zeros to figure out where could this function go from being positive to negative or negative to positive. At this point in time, we would want to underline any VIPs that would make the denominator equal to 0 because those are problematic VIPs. We don't need to worry about problematic VIPs in this example because it's a polynomial. I'll make a note of that right here. There are no problematic VIPs in this example. All right. So I'm looking at this guy. He's already factored. From this factor, the 0 is 5. If we set this factor equal to 0, we get -2. These are my two VIPs right here. These are the only places that the function could possibly dip above or below the x-axis. The next step is setting up a sign chart using these VIPs. If we had a problem with problematic VIPs, which are, again, ones that make a denominator 0, we would circle those and pay close attention to them, but we don't need to, we're good here. These sign charts are really, really important. You're going to do something like this again in calculus. Getting good at sign charts now is only going to benefit you. So I'm putting my zeros, my VIPs, putting my VIPs in order on my number line. You don't need to make tick marks showing all the numbers. It just needs to be in order so that it makes sense, right? Negative infinity is down here, positive infinity is up here, -2 is smaller than 5, that's why it comes to the left of 5. So I'm putting all my VIPs down, and then I need to choose test values within each interval. If I look back here, what that test value would be, it'd be like me choosing, if I chose like, what is this? -3 as a test value. If I found the y value at -3, I would find out that the y value is negative. And if I chose a test value at 1 in this interval, I would find that the y value is positive. So the intervals we have are the zeros of the function They're separated by the zeros of the function. And essentially, we're just going to be testing x values at each of these places. Right? There's one chunk here, another chunk here, another chunk here, pink, another chunk here. We test values in each chunk of the graph that is separated by the times it hits the x-axis to see if it's positive or negative, if the function is positive or negative. So I'm going to take test values within each interval. We cannot choose a VIP as a test value. I will write this down. I'll pause and write. Right. So choose test values within each interval. Do not choose any VIPs for test values. -2 and 5 are our VIPs. So a number that's between -infinity and -2, I'm going to choose -3. A number between -2 and 5, I'll choose 0. And a number greater than 5, I'm going to choose 6. The next step. All right, this is going to look different the first time I do it than how I do it subsequently, but we have to do it slow. We are going to be taking each of these factors, and we are going to be plugging in our test value to these factors. At the end of the day, I don't really care what number comes out. I just care if that number is positive or negative. So I'm going to be plugging for this first interval -3 into both of these factors. Normally, the way that would look, let's say for x minus 5, -3 minus 5, and then for x plus 2, we'd have -3 plus 2 squared. So normally, we would do this. We'd say, oh, -3 minus 5 is -8, and -3 plus 2 is -1 squared. And it doesn't matter what this comes out to. All right, it doesn't matter that this will become -8. The way that we're going to go about these problems is just caring if it's negative or positive. So -8, that's a negative. It's a negative number. -1 squared, anything squared is positive. So negative times a positive, that gives me a negative. This entire interval is going to be below the x-axis. It'll be negative. So I don't really need to plug in my value and get a number. It is enough for me to do the mental math and just determine if each factor is positive or negative. So for instance, if I'm plugging 0 into this blue factor here, 0 minus 5, that is a negative number. Negative number. You know what? Why don't I just do this and then make it big as well? If I plug 0 into x plus 2 squared, 0 plus 2, that's 2, it's a positive number. If you square a positive number, it's positive. If you square a negative number, it's positive. A negative times a positive is a negative. Right? This is how my sign charts look. Alex does theirs slightly differently. I think mine are better, but I'm also biased. Right. Then we're plugging in 6. So 6 minus 5, that's a positive number. 6 minus 5 is 1. 1 is positive. And then this thing is always positive, right? If I square it, it's going to be positive. I don't even care what happens there. It's going to be positive. And a positive times a positive is a positive. From here, we use a sign chart to solve the inequality. So we were asked, when is this thing less than 0? If you have blah, 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 blah function less than 0, you're choosing the negatives. If it's greater than 0, you're choosing the positives. So we are negative in these two areas. This inequality was a strict inequality. There's no underline. That's going to mean that we exclude -2 and we exclude 5. And then we are taking this interval here, so the one we circled, everything in this interval will take. This interval is also negative, so we'll take this one. And this interval is positive, so we won't take that. We can write our inequality based upon the graph we have here. So this is a two-part inequality. The first part of it is from -infinity to -2. We exclude -2, and then we go to 5. And that is our full answer. -infinity to -2 and -2 to 5. Again, we don't include -2 because this is a strict inequality. If we were to plug -2 in, come down here. Boom, 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 boom. If I were to plug -2 in to this inequality, we'd get -7 times 0 squared is less than 0. So we'd get 0 less than 0, which is just not true, right? 0 is not less than 0. 0 is equal to 0. So -2 can't be included. That's why we're excluding him. The same thing would happen with 5, and that's why we exclude 5. In general, if you have a strict inequality, you're looking at open circles on all of your VIPs. This little graph over here is, in fact, the graph of f of x equals x minus 5 times x plus 2 quantity squared. Right. So right here, this is -2. Right here is 5. And notice, indeed, that this entire area is below 0 and that we can exclude -2 because that's where it hits the x-axis. So from -infinity to -2, the graph is under the x-axis. From -2 to 5, the graph is under the x-axis. So let's do a few more polynomial examples, then we'll do some rational function examples. Scrolling down, solve and write your answer in interval notation. Notice my first step is supposed to be making sure that one side is 0 and that the entire thing is factored. So I'm going to move the 12 and the 10x over to the left-hand side by subtraction. 12x squared minus 10x minus 12 less than 0. I know I can factor a 2 out. If I factor a 2 out, I get 6x squared minus 5x minus 6 less than 0. Using whatever factoring method makes you most happy, you can factor that quadratic into 2x minus 3 times 3x plus 2. My VIPs. If I set 2x minus 3 equal to 0, I get x equal to 3/2. If I set 3x plus 2 equal to 0, I get x equal to -2/3. Genuinely, this is simply 2x minus 3 equals 0, so 2x is equal to 3, x is equal to 3/2. That's how I'm getting this 3/2 right here. And the same would be said over here of the -2/3. Alrighty, tidy. So I have a total of 2 VIPs. And so I'm going to duplicate. I'm going to put both of these VIPs on here. We have -2/3. We have +3/2. I'm going to choose test values within the interval. So I need a number that is between -infinity and -2/3. I'm going to choose -1. So -1 is less than -2/3. A number between -2/3 and +3/2. If you're looking for a test value between a negative number and a positive number, choose 0. Whenever you can, choose 0. It makes the math easier in your head. Finally, a number that's greater than 3 halves. 3 halves is 1.5, so I'm going to choose 2. Be very careful in choosing these values if you choose a wrong value. So if I chose, let's say I chose 1, 1 isn't in this interval, so it'll mess up everything. So be careful, especially with negative numbers, that the numbers you're choosing truly are within the interval. Over here, we have we have 3 pieces. So we have this one factor, our second factor, and our third factor. Okay, let me just kind of do a little highlighting before I do anything at all. For each of these intervals, I am looking to determine whether the blue, green, and pink factors are positive or negative based on this test value. 2 itself, the blue one, is always positive. That's a positive number. 2 is a positive number. I can just throw that positive in there. Good. Now, mentally, all I have to do is plug -1 into the green factor and say -1 times 2 is -2, -2 minus 3. Doesn't matter what it is, I know it's negative. A negative minus a number is a negative. -1 plugged into the pink factor. 3 times -1 is -3. -3 plus 2 is -1. That's negative. 2 negatives make a positive, so this interval will be positive. Plugging in 0. 0 times 2, that's just going to go away. Minus 3, that's negative. 0 times 3 is 0. 0 plus 2, that's a positive number. 1 negative makes a negative. Plugging in 2. 2 times 2 is 4. 4 minus 3 is 1. That's a positive number. 3 times 2 is 6. 6 plus 2 is a positive number. 3 positives make a positive. We have less than 0 here. If we have less than 0, that means we're choosing the negatives. This is a strict inequality, so I am putting open circles on our endpoints, and I am taking everything in here, right? Taking everything between -2 and 3 halves. Our final answer, taking it off the number line and into interval notation, is -2/3, comma, 3 halves. The interval between -2/3 and 3 halves. Let's do one more example. I am going to start by making one side 0, so I'm going to add 15x squared to the other side. This is greater than or equal to 0. I am factoring out 3x squared. That leaves me with x plus 5 greater than or equal to 0. Oh, let's not make those yet. So looking here, you could treat this like it's 3 factors, sort of like we did above. I'm going to treat it like it's 1. I'm going to treat 3x squared like it's 1 factor. Here's the thing about 3x squared. 3x squared is always going to be positive because x squared is positive, and a positive number times 3 will be a positive number. If you set 3x squared equal to 0, you're going to get x equal to 0 as a VIP. For x plus 5, you're going to get -5. So I have 2 VIPs. I have 0. You know what? Let me delete and just duplicate. We have 0. Oops. See, I put 0 here. I should have put -5 here. -5 and 0. -5 has to come before 0. So I have -5. I have 0. I am now choosing test values. So a number less than -5. I'm going to choose -6. A number between -5 and 0. Remember, you can't choose 0 here because 0 is a VIP. I'm going to choose -2, and then a number greater than 0, I'll choose 1. Once again, this factor right here, 3x squared, will always be positive because x is squared. The most it could be is become 0, but we can't choose 0 because 0 is a VIP. Any other number besides 0, if you plug it in, will give you a positive. So I'm just going to put in positive here. We know it's going to be positive everywhere for that first factor. That means all we have to do is plug in our test value to the second factor. -6 plus 5, that's -1, which is negative. A positive and a negative make a negative. If you multiply a positive and a negative together, you get a negative number. -2 plus 5 is a positive number. A positive times a positive is a positive. 1 plus 5, that gives us 6. That's a positive number. A positive times a positive is a positive. Here, we had greater than or equal to 0, and that means we're choosing the positive. There we go. So we have these two that are positive. Notice that this is a greater than or equal to. So instead of having open circles, we're going to have closed circles. Right? I'm putting closed circles here. And when I fill in the intervals that are positive, this one's positive, and so is this one. Notice that there's no gap between these two intervals. When we did this problem up here, there was an open circle hole, so we had to put it into 2 intervals. We do not want to write this as 2 intervals because it's all one continuous interval. We're not skipping 0. 0 is included as an answer. So our answer is going to go from -5 to infinity. It's going to be this entire interval starting here at -5 going all the way to infinity. If this were a strict inequality with no underline here, then we would do an open circle at 0 and we would skip it. You don't want to write this as -5 to 0 union 0 to infinity. This would be incorrect. This is incorrect because 0 is included twice in here, right? That doesn't make sense. We wouldn't write it like that. We would only write it as -5 to infinity. Oops, that's not, that page is for rational inequalities. So we will be doing rational inequalities in the next video. Spoiler, they look like this. They are fractions. But this is polynomial inequalities. I hope you enjoyed. I'll see you in the next video. Bye.